I'm not sure. I didn't see this in school. We saw fx equals and then
Okay, it's just a starter. So this is the point 1, 2. If it's moved by the vector 3, 0, that means like 3 to the right.
okay. So um 4 2.
Yeah. And B.
Okay. Uh mm, -3 -3 2.
Yep, that's it. Okay, let's say 1A. Any idea about that?
Um 7.
Yes.
It's
So the f of 2 is 7. How about... No, I think you'll be fine for those. Hang on, let me think about this. Let's try 2B.
Find the value of, okay. Um
2B.
Wait, so x equals g3 plus 2? No. I don't understand the layout.
So y is equal to the g of x plus 2.
Okay. Um Not sure.
What is the g of x?
Oh, okay, 5x plus 2. So 5x plus 2, um, plus 4, 5x plus 4?
That's it. And so if you have the g of x and you add 2 to it, it's basically just your final answer 2 bigger. And so that's going to move it 2 up.
Okay, but
Well,
you know how the... Okay.
we'll look a bit more at that in a minute. Okay, part 2.
Um, 5x plus 4?
So this time, instead of x, you have x plus 2.
Okay, so...
So wherever there's an x, replace it with an x plus 2 in a bracket.
Okay, yeah, so 5x squared plus 4?
So you see how x became x plus 2?
Yep.
So this one, 5x, replace the x with, in a bracket, x plus 2.
5x, okay, plus 10 plus 2, so 5x plus 4.
That's it.
Okay.
And so it's just like with 1a, x was replaced with a 2, or I should say x is substituted with 2. And so x plus 2 is substituted. So so they're two different things if the number is on the outside of the bracket and numbers on the inside. And it's just substitution, just a different way of writing substitution.
Okay.
Any questions about any of that?
You know the first example that we did?
Yeah.
5x plus 2 was in a bracket because x was in a bracket, yes?
Yes. So
shouldn't that have been multiplied by 2?
this one, is it?
Yeah.
It has 2 added to it, but it's not being multiplied by 2. So the g of x is 5x plus 2. In the second one,
Okay.
we were substituting the g of x. In the second one, we were substituting x.
Okay. Okay.
Yeah, and you're right. The bracket didn't change anything. Quadratics. You have this is equal to 0. What are the two answers?
So you have to find the number there. Oh, sorry. 2 or -3.
That's it.
Cool.
So x equals 2 or x equals -3. Now, if we were to do the f of x plus 7, we would be replacing x with x plus 7. And so x plus 7 equals 2, or x plus 7 equals -3. And so what are the new solutions?
-5 or -11. No, -10, sorry.
Yes. Excuse me. The quick way of doing this, we went from having 2 to -5. We went from having -3 to -10. What's the quick way of going from 2 to -5 or -3 to -10? What happened there? What do you have to do to 2? What do you have to do to 2 to turn it into -5 to -3 from -10?
So 2 times -2.5.
Okay. What works for both of them? Because that won't work for the second one. Or how did we actually... What happened to the 2 in our question that made it into -5?
I'm not sure.
The first answer was 2, and then the second answer was -5. So why did it become -5?
Oh, okay, so x plus 7 is... Yeah?
Yes. Yeah, it's basically because you had to subtract 7 from both sides.
Oh, okay. Okay.
And so when you do f of x plus 7, let me just write that a bit later. When you do the f of x plus 7, you have to subtract 7 from all the x's.
Okay.
And we could do something similar, like if we were to put in the f of x minus 2, you would go from having x equals -3 to x minus 2 equals -3, and you would have to add 2 to both sides. So that would be +2 to the x's. And so it's always the opposite sign. So the f of x plus 7, you subtract 7 from the x's. F of x minus 2, you add 2 to all the x's because it changes sign when you bring it to the other side.
Okay.
So that's just kind of proving it. And now let's just use it. Let's see, is that too different? Let me just see what we have here. Let's see. Might be a bit tricky. Yeah, let's do this one. No, let me just bridge this a little bit. So let's say x equals 5 or x equals 11. What is the f of x plus 3? And what is... So that's part A. And then part B, x minus 4. I'll say x minus 1. Okay, let's try part A. How do we do that?
So substitute the x for 5. You get 8. No, I don't know.
X becomes x plus 3.
Bye, thank you.
So just by substitution, wherever you see an x, it becomes x plus 3.
Okay.
So instead of x
Okay,
equals
so
5,
x plus 3 equals 5.
yep,
So x equals 2.
yep. And so
And we have,
x
we have
plus
to do the
3,
same with.
yeah, x plus 3, what did that do to the x? It was 5, it became 2.
It was minus 3. Okay.
Yeah,
And so x equals 11 will probably just be minus 3 also. So 7, no, 8, sorry, 8.
that's it. And part B.
Mm, so 4. Wait, sorry. No, 6. Or 12.
Well done. Okay, so it changes sign because when you bring it to the other side. Okay, this is the graph of y equals x squared. Y equals x squared usually looks like this. Any idea what this graph is?
No, I'm very bad at this. Is this something that we should learn by heart?
No. So y equals x squared is at 0, 0. Its minimum is at 0, 0. If x had 1 added to it, then this is the graph of x minus 1 squared. Because it's always the opposite sign.
Okay.
So how about part B? This time it moved 1 to the left.
Squared.
Say it again, sorry.
X plus 1 squared.
Well done. Next one, C.
Okay, x, and then it would have to be closed brackets minus 1. I'm not too sure. I'm trying to remember what we did in class.
It moved 4 to the right. Are you looking up this one?
Oh, sorry, I thought. Oh, no. So x minus 4 squared also.
Great. Okay, so now I think it's the one you were looking at.
Yeah.
Yeah, go on. What was this one?
Y equals x close brackets minus 1.
And I'm just going to make this a bit more understandable.
Yeah.
You know how you went 1 down on the y?
Yes.
And so because it's the opposite sign, it's y plus 1 equals x squared, and the x didn't change. So these are all transformations of y equals x squared.
Okay.
So when it moved 1 to the left, it was x plus 1. It has moved 1 down, so it's y plus 1. How about E?
Okay, so y minus 2 equals x squared.
Well done. Okay, tricky one. F.
Right. Y plus 1 equals x minus 4 close brackets squared.
Not 4. What's the x coordinate of the minimum?
Sorry, I was watching the alarm again. So, okay, x minus 1 then?
This one?
Yeah.
The minimum was originally at 0, 0.
Yeah.
It's now at 2 minus 1. And so what happened to the x?
It went down by 1 times minus 1.
The x went right 2. And so what transformation would add to all the x's?
I'm not sure.
It would be x minus 2. That would add to all the x's.
Wait, so y plus 1, why is that y plus 1?
So the y went down by 1, so it's y plus 1.
Okay.
And it went right 2, so it's x minus 2. So it's always the opposite sign, because you bring it across the other sign. Okay, how about you?
And
sorry, go on.
what if the... Okay, we'll probably see that later. Just if, for example, minus 2 is outside the bracket. So x, close bracket, minus 2.
We'll see it after we do these.
Okay. So for g, y plus 1.
It went up by 1, and so you want the opposite of up by 1.
Okay, y minus 1
yep.
equals x minus 4 squared.
Brilliant. Okay, now let's do that thing you were talking about. So let's go back to part D. You know how it was y plus 1 equals x squared?
Yeah.
Make it y equals, what would it be? Because we usually write them as y equals.
X squared plus 1?
You have to move plus 1 to
x squared minus 1. Yeah.
Yes. And so the one underneath it? E?
X squared plus 2.
That's why it goes x squared plus 2. One underneath it?
X minus 2 close bracket squared plus 1. Minus 1, sorry. Minus 1.
Minus 1, yeah. And so what you can do is, if you prefer, you can do it in one step. It's because we don't usually write equations as y plus 1 equals or y minus 2 equals. We usually just write it as y equals. And so because you bring the number to the next to y to the other side, that is not in a bracket. If you look at the answer for F, it's not in a bracket next to the x, it's outside the bracket. And so the number inside the bracket is the x, and the number outside the bracket is the y. And because you brought it to the other side, it's now back to its original sign.
Yep.
So let's try h any way you like. What would be h? And get your final answer as y equals.
Okay, so I would say so if I do the working out first, I'd say y minus 3 equals x plus 2 squared. And then so y equals x plus 2 squared plus 3.
That's it. And and that's why what's in the bracket is the x and what's outside the bracket is the y. It's also why the x has the opposite sign and the y has the same sign, because it was originally the opposite, and then when you moved it, it went back again.
Okay.
So any questions about any part of that?
No.
So it's a very challenging topic, a lot of stuff backwards. Okay, here's the graph of y equals sine x. This is what it normally looks like. Match them up. Which of the two on the bottom is this one, and which of the two on the bottom is this one?
So the plus 0.5 is the y here, yes?
Yep.
So that doesn't give us much clue for now.
Okay, so how about the x plus 31?
Yeah. I would say B. because A goes to B. No, sorry, yeah, you're right. B goes to B because x plus 30, and I feel like graph B. I'm not too sure. It goes in 30s, so 120 plus 30 is 150, and so on.
So basically, this one moved 30 to the left. It was originally started at 0, 0. Now it starts at minus 30, 0, and so it's the opposite sign, x plus 30.
Okay.
Why is this one the same sign? This says plus 0.5 and it's moved up to 0.5.
Okay, but the other one's moved up to 0.5 as well, hasn't it?
Yes. Well, what happened was it moved left. It's just that part went through at 0.5. So that part is there. The one part A, why did the graph not move down by 0.5?
Because it's plus.
Yes.
Because it's the y maybe.
Yeah, if you brought it to the other side, it would be y minus 0.5. They brought it to the other side, and so it was the same sign. Yeah. Okay, let's see. Y equals sine x. Find the equation of each curve. That's a challenging one. Yeah, let's do this one.
Okay. So for A, would the x be on the two places to the right?
Yes, and if so, do you know what it's called, the type of transformation when it just slides up or down, left or right?
No.
That's called a translation.
Okay.
So, if we go all the way back, this one, translation. This is why we did that starter. So it just moves it left or right, up or down. This one was a translation, and we do it as a vector. So it moved 2 to the right, and then 0 up or down. And all of these will be translations, I believe. If it's a plus or a minus, like if it's adding or subtracting, then it's just a translation. How about B?
So 2 places to the left then?
Yeah.
Translated 2 places to the left.
And what was that?
And so minus 2 over 0?
Yes. And I won't bother writing down translation every single time, but you're right, they are all translations.
Okay.
Part C.
So y moves 1 place to the right, and so 1, and then y moves 1 place upwards, I'd say.
Yes.
So 1 as well.
Well done.
Okay, so when it's plus 1, for y, it's plus 1. There's no...
Yes, and that's because they already moved it onto the other side of the equal sign. So it's...
Okay.
Yeah. Okay, part D.
Two places to the left, so minus 2, and 4 places upwards, so 4.
That's great.
I have a question.
Yes?
Every time we've been doing examples, it's been squared. If it was just x plus 2 plus 4, x plus 2 in brackets plus 4, would that just be... How would that be?
So it depends on just what was the original. Was the original y equals x plus 2?
Okay.
So what is the original and what is the new one? So what the original is like y equals x plus 2?
Yeah, okay.
And then the new one is y equals x plus 2 Plus 4, is it?
Yeah.
Plus 4. Well, let's call this one the f of x. And so if this one is y equals the f of x, then what is y equals the f of x plus 4? What translation is that?
Four places to the left.
That would be if the plus 4 was in the bracket next to the x.
Okay, so four places upwards.
Yes. And so 0 on the x and 4 up.
Okay, wait. So. Okay. Yeah.
And the f of x is just short for whatever equation you're using. It could be x squared, it could be x cubed, it could be something quite long like 3x squared plus 7x minus 9. But it's just the same rule applies for all of them. If you add 4 outside the bracket, that moves it the final graph 4 up, even if it's a strange graph like a sine graph.
Okay. In the example, y equals x plus 2, x equals x plus 2, yes?
What? Say it again, sorry?
In the example that we just done, y equals x plus 2, x plus 2 equals x, yes?
No. I think you might be thinking of something else. Let me... so let's change it slightly. I think what you're thinking of is... let's use x cubed just to change it a bit. Y equals x cubed, and then that becomes y equals x plus 2 cubed. So what transformation has happened there?
Y equals fx plus 2?
Yes, and so it was originally y equals the f of x, like some function of x. Then the new one was y equals the f of x plus 2 in a bracket. And so what translation is that?
Just plus 2, I guess.
To the x or y?
To the x. So the translation is 2 places to the left.
Yeah, or minus 2?
Minus 2, 0.
Yep, that's it.
Okay.
And so you can use x squared, x cubed, sine x, but in general it's the f of x.
Okay. Do they normally give us the original in the exam?
Sometimes, and sometimes they'll just use the f of x. And it shouldn't matter. Like you can see here, here this was a translation of minus 2, 0, and here this was also a translation of minus 2, 0. For the bottom one, it was a translation of 0, 4, and for in f of x notation, it's also 0, 4.
But in are there any, for example, graph shapes that we need to learn? That you would say just.
There might be some that are helpful, but that's kind of a different thing.
Okay.
Transformations of graphs you think of. Let's just do f and g, if that's all right.
So 2 places, just plus 2 minus 4.
And g.
So I think the minus 2 might be y, so 0 minus 2.
Yeah, that's it. Well done. Okay, so here's graphs like you're talking about. Okay, what's going to happen to the first graph? Y equals f of x minus 1.
The x is going to move one place to the right.
Yes, and so basically any main point you can see, just move it one place to the right, and then just redraw the graph. How about the next one? Y equals the f of x
Oh.
plus 2.
So I think y is going to go up by 2.
Yeah, so again,
So,
every main point, just move it up by 2.
so just to clarify, anything that isn't in a bracket is y. Anything that is in a bracket is x.
Correct.
Great, perfect.
And how about C?
Down by 1 to the left by 1.
Yes, left 1, or that's the vector minus 1, 1, and it's a translation and same thing. Okay, how about this one?
Sorry, just to come back to the last slide, you said minus 1, 1, but aren't they both going towards a negative direction? So shouldn't it be
Sorry, minus 1,
minus 1?
minus 1, minus 1. Yeah,
Okay,
my mistake.
great. Thank you.
So this graph, what's going to happen to it if you do y equals the f of x plus 1?
It's going to go up by 1.
Yes, and so you can see this point here, maybe move that up by 1. 2, 4 becomes 2, 5, that type of thing. Minus 2, 4
Okay.
becomes minus 2, 5. And so on. Yeah, you get the idea there. So this is a quadratic graph. This is a cubic graph. So it describe the transformation here. So it was originally the red graph. It's now the blue graph. And so so the red graph is y equals the f of x. What is the blue graph? Equation of the blue graph.
Y equals the f of x plus 2.
Well done. And that's
Okay.
the bracket. And yeah, that was translated 0, 2. That's more of the same, just a slightly different looking graph. Describe. This is a compound. That's okay. Let's do this one.
Well, it's going to go up by 1.
Nope.
And sorry?
Not up by 1.
Sorry. To the left by 1 and up by 3. And so the vector is plus 1 plus 3.
Yes. And so it'll actually be 1 right instead of 1 left.
Yep.
And what type of transformation is this if you're adding or subtracting?
Translation?
Yes. So it's
Okay.
translation by the vector 1, 3. Okay, let's try these two.
It's going to go to the... Oh, it's not in the bracket, so up by 1. So 0, 1 is the vector.
Mm-hmm.
And then for this one, it is in the bracket. So I would say it's going to go to the right by 90 degrees.
Mm-hmm.
So is that, I don't know what the vector is for that.
Just 90, 0.
Okay.
Or 90 degrees, 0, something like that. Yeah. So this is trig, and so they're using, bigger numbers, like 90, 180, 360. It's the same idea.
Okay.
That's more the same. It's more the same. I just want to move you on to... Okay, exam question. Let's try this.
It's going to go down by 3 So it's going to be minus 1. Sorry, 1 0 or
0.
0 1.
Yeah,
Sorry,
0 1.
x plus y. Okay.
That's it. Okay, how about this?
Direction cover equation. Coordinates for the maximum. I'm not sure really. Write down the coordinates of the maximum point of the curve with equation. Okay. Could it be so moving minus 3 to the left? So it's going to be 0 5.
Brilliant.
Sorry, it took me some time.
No, it's good. And B.
Describe the transformation. So as the vector,
Yeah, fully.
0, 0 minus 3.
Part B is different.
Oh, sorry. The curve with equation y equals fx each other. Well, so it's going to be down by 4. Still from 3 to 5, yes?
They just want you to describe the transformation.
Okay. Just 0 minus 4 then.
And that's 1 mark. What's the second mark for?
Writing down translation.
Yeah.
No, if they've already done it in the question.
Yeah.
Oh, they've already done it in the question.
They said transformed.
Okay.
Transformation is similar, like it is in general. It's because you can have something like an enlargement. That's a different type. 1 markers. How do you feel? No. Let's see if there's 2 markers. Okay, how about this?
The graph of y equals fx is shown on the grid. On the grid above, sketch the graph of y equals fx plus 3. So it's going to be minus 3, so 3 to the left. So
Okay.
I think it's going to become minus 5.
And can you find, so for a quadratic, can you find 2 other main coordinates? Something like that?
Minus 4 will become minus 7 4.
Yeah.
And 0 4 will become minus 3 4.
Great. And so once you have those 3 points, you should be able to sketch it. That's it. Great. How about this?
Okay, just plus 1 to the right, so it's not, I think it's going through minus 1, now we'll be going through 0.
And for a straight line, 1 more coordinate?
It's going through minus 2 on the y-axis, so now we'll be going through minus 1, 1 minus 1.
You said 1 right, just move it 1 right. So this point here, move it 1 right, where is it?
1 minus 2.
Yeah, so don't overthink it, literally just move everything to the right. So for the for the quadratic in the previous question, we needed 3 points. For a straight line, you only need 2.
Okay.
3 is also fine. Yeah, so we moved it 1 to the right. How about this?
On this grid, sketch graph of y equals fx minus 3. Okay, so it's going to go plus 3 to the right. So on this graph, sketch the graph of y. Okay, so the minimum will become 4 minus 1, and then minus 1, 3 will become 2, 3, and 3, 3 will become 6, 3.
Well done. Great. And you would draw that as best you can. And how about this?
I think I saw this just before this. Let's go sketch a y sin x plus 2. Okay, so I think it's y. So it's going to go up by 2. So 0.00 will go to 0.2. Point.
And actually,
I think it's.
Are there any other points that were on the x-axis?
Yep. 180, 0, sorry.
Yeah, so that's going 2 up as well. Any other?
Do they have to be on the y-axis, or can I take some that are underneath?
No, just take the main points. But okay, yeah, go on.
Okay.
Main points.
That's, I think there's 91.
Yeah. Where is that?
Yeah, that one. And it'll go up by 2.
Yeah.
So now it will become 93.
Yeah, basically all these main points. 1, 2, and this one down here. 1, 2.
Okay.
And we do our best. Great. Yeah, moved everything 2 up. Okay, a transformation has already been done. You have to say what it was.
The f of y equals the f of x. Y equals the f of x, and then in the brackets minus 6.
Well done. Great.
Sorry, is it not squared? Just I don't know. I'm asking.
Well, it looks like y equals x squared.
Yeah.
But they just named it y equals the f of x for short.
Okay, so no need to write. Okay.
Yeah, because it could be squared, it could be cubed, could be could be anything. That's it. So that's translating functions. So how do you feel about those?
Probably a half, to be honest.
It's tricky stuff.
I'm beginning to do quite well, but yeah.
I think I'll just show you this one. So you can do translations, which are if it's adding or subtracting something. If an x changes to a minus x or a y changes to a minus y, then it's a reflection.
Okay.
And if they're multiplied by a number, then it's an enlargement. And so those are the 3 types. And it's the same thing again and again, and you just have to just kind of practice them. So I don't want to.
So minus f is a negative y.
Yes, a minus x is a negative x. But we could go through that. It's very good. I just want to see. I have a little test at the end. See how we do. Yeah. That's enlargements. So this is our test. No, maybe I'll save that. Maybe I'll save that for another time because I think you've done enough of that stuff. So let's see. So translation, yeah, just moves it up or down, left or right. So this is function notation. Function notation is just substitution. So let me give you a slightly different one. Y equals, no, I'll just call it the f of x. The f of x is equal to x cubed plus x squared minus x plus 3.
Yeah.
What is the f of 2?
2 cubed is 8
Mm-hmm.
plus 4 minus 2 plus 3. That gives us 12. 12 minus 2 is 10 plus 3, 13.
Yes. What is the equation of the f of x minus 5? So just as an equation.
And then substitute 13 into x, so...
No, part B, different question. So up here is the f of x.
Yep.
And what is the f of x minus 5?
I'm not sure.
So you know how...
What am I looking for?
So you... well, okay, so the first bit would be x minus 5 cubed. So it's just...
Oh, okay, yes. So it's the structure of the one above. Okay, so x minus 5 cubed plus x minus 5 squared minus x minus 5 plus 3.
Well done. And so actually if you saw something like that where all the x's were all changed the same way, then that's a transformation. So function notation is very useful for substitution. Here, instead of having to write out substitute 2 for x and write your answer, all they have to write down is the f of 2. They've substituted 2 for x. You can also do it algebraically. They've substituted x minus 5 for x. And so you don't have to go drawing the whole graph all over again. You can just see that means 5 to the right. And so there you go. We don't have to figure out what the new equation is. You can just replace all the x's with x minus 5. And there you go.
Mm-hmm.
Otherwise it'd be quite difficult. Where it all comes from, the reason why the x's are the opposite sign is because you have to bring the number to the other side.
Yeah.
And the reason why the y is the same sign is because the person who did it has already brought it to the other side.
Okay.
Because they just made it y equals again, which is how we usually do it.
Yeah.
Yes, so graphs. So we practiced that for graphs. I think that was okay. Sine graph seems to be common now. So you can do it with anything. It can be x squared, it can be x cubed, or just in general, the f of x, any function of x.
Okay.
Follows the same, these rules of 1 to the left, 3 up, all of that. We do a quadratic curve, cubic curve. We did it with one translation, did it with a compound, so it moved in 2 directions. We did exam questions, yeah. So this one was just saying, for this new curve, where would be the new maximum? And for that same curve, what is the transformation? And you just have to make sure you say it's a translation, because it could be a reflection if they change sign, or it could be a enlargement if they were multiplied by a number. F of x minus 6, yeah. I can't hear you for whatever reason.